Undo the same operation on both sides.
On the foxglove equation path, linear equations exist as physical, balanced structures resting on roots. Solving them requires navigating a landscape where every quantity has weight and position. Look closely at the surface of this route. Finding unknown values along this trail depends on observing what shifts and what remains securely fixed. An unnamed red fox serves as our guide, tracking the scent of balance through the undergrowth to reveal the logic of the path. By watching the environment first, we see the physical quantities and their relationships before they are formally named. This carved bark shows a structure where an unknown quantity has been divided into 4 equal parts, leaving exactly 6. We undo that division by gathering 4 groups of 6. This physical multiplication by the denominator restores the whole quantity. Scaling both sides reveals that the original undivided quantity is exactly 24. This arrangement of stones proves the balance. Dividing 24 into the original 4 parts yields 6, keeping the path steady. The inverse operation of multiplication physically restores the balance needed to find the original total. This boulder presents a multi-layered obstacle. A variable is doubled, and 7 extra units stand in the way of reaching 21. We peel back the first layer by physically removing those 7 units.
Divide both sides by the coefficient 2.
Subtracting them from both sides leaves the doubled unknown balanced against 14. To find the value of a single variable, we split the remaining 14 in half. Separating 14 units into 2 equal groups reveals that x equals 7. Removing the constant term first clears the structure, creating a direct route to isolate the variable through division. Here, a variable is trapped inside a group. We have 3 identical bundles, and together they total 18. If 3 bundles hold 18, we can deduce the value of just 1 by separating the group. Dividing both sides by 3 strips away the multiplier, showing that the contents of a single bundle equal 6. Finally, the fox removes the 2 extra reeds from the bundle. Subtracting those internal units isolates the exact variable, 4. Grouped quantities act as protected blocks. Identifying and isolating the entire group first simplifies the path to the solution. Each step the fox took, from grouping acorns to clearing stones, mapped directly to the algebraic moves required to maintain balance. The collection of values we uncovered along the route forms the solution set for these equations. Mathematical notation serves as a formal record of these physical relationships. These final values are the evidence of a path properly navigated and balanced. Consider the fox's journey. Which specific physical action, like removing stones or dividing quantities, proved the mathematical truth of the solution?
Check 7 in the original equation.